Hi Sigmas, welcome back to Star Talk Junior. I'm Phoebe Wolf.
I'm Shrijin Singh.
Today we will be talking about dimensions and wormholes. So let's first picture what are dimensions? I mean, obviously there's like the first dimension, the second dimension, the third dimension. And I'm going to start off with some analogies to help us visualize it. So the first one is called Earth to the Moon in time. So imagine if the Earth and the Moon were just 1 millimeter apart, which is like way smaller than an inch. And on that scale, the distance from Earth to the nearest star, Proxima Centauri, would be about 250 miles. And that's like driving from New York City to Washington, D.C. And that's like our nearest star. So, and from New York to Washington, D.C. is like a very long time. Like, I could not sit through that drive.
Yeah, that's like crazy. Another example is imagine you're holding a grain of sand, okay? And that tiny grain is basically a representation of a small area of the sky. And in that pinpoint, the Hubble telescope, it captured over 10,000 galaxies. Each galaxy in that speck could have billions of stars and trillions of planets. One small grain of sand.
Our next analogy is a sun as a grain of sand in Times Square. And so place like a grain of sand in the middle of the Times Square and imagine that's our sun. And on this scale, Earth would orbit just like a tiny, very small distance away within your fingertip range. And that is basically our sun, but our closest star would be about 6 blocks away.
Okay, I want to give an example that personally helped me understand the vastness of our universe. Okay, you know our human brain. We have neurons in our brains, which are basically these messengers that carry a message from one nerve to another, right? So now our brain has approximately 86 billion neurons, which is compared to the 100 billion stars in the Milky Way. It's as if each of our brain contained a galaxy of its own. So like stars in the galaxy, neurons are interconnected in complex ways. When you looking at the stars, you're looking at like this intricate network of connections that's cosmic in its own way.
Well, okay. So the next analogy we are going to do is the universe as an ocean. So think of the universe as like a huge ocean and as a boundless ocean. And each galaxy, and for context, the Milky Way has about 100 billion stars, and each galaxy is a tiny droplet within it. And our Earth is one electron in that droplet, a minuscule point of life in a sea that stretches so vastly in every direction that even light would take billions of years to cross it. So, like one tiny droplet is a galaxy in a huge sea. That's how big the universe is.
Crazy. I mean, if you take a moment to visualize that, I mean, beyond our capabilities.
Even light takes like 50,000 years to reach one side of the galaxy to another, and that's just one tiny droplet.
I mean, it's wild.
Okay, so we're going to start with the zeroth dimension, and it is like a point without existence. This point is called the singularity because it's infinite density, which, by the way, Einstein suggested that we might actually be living inside this point, inside of a black hole, which is crazy to think about. But anyway, this is the zeroth dimension because there are no dimensions, but it's just infinite density.
Then we have our first dimension. So think of the earliest moment of our universe, like right after the Big Bang, right? Or even like during the Big Bang. It's a single line of energy just stretching forwards. There's no complexity. Simple, like down to like straight blocks, or I guess lines in this case. And it's just moving like a light source, like moving from one point to point A to point B.
The next dimension is the 2D dimension, and it's basically like up and down. It's like the directions, but just not 3D, so it doesn't have depth or weight for that matter, but it goes like it's just straight lines, you know?
Next, we have 3D. So 3D is basically everything you see around us, everything you see around you and me. Basically, that.
And the fourth dimension is time. So, time is like a pathway through reality, and the fourth dimension enables you to go through time. Like, for example, if my hair tie here is there is time like stretching out in a graph. That's obviously invisible to us because it's in the fourth dimension. That's actually there in a different dimension, and if you can control the fourth dimension, then you can move through that time.
Mhm. And last but not least, the fifth dimension. Or I guess there's one more. We'll get to that. So now imagine that every decision, every quantum fluctuation that's possible branches into a new reality. Think multiverse, think Doctor Strange, think the Marvel movie, what's it called? The Ant-Man and Wasp. I think that's what it's called. And now the fifth dimension, basically, it contains all possible outcomes of our universe. A vast tree in which every branch is an alternate version of events that could have occurred.
Yeah. The sixth dimension is infinite universes with unique histories. And the sixth dimension encompasses every single version, which is like crazy to think about because it's like the multiverse. Like if you do something, and then there are so many more ways that it could have been done. Like for example, if I'm picking up this pen, then it could have been picked up like this or this or this. And in the sixth dimension, all of those different possibilities create a new universe, which is astonishing to think about.
So I guess in another universe, we get to live in Harry Potter.
Yeah, one of them. Like,
So with me, I have a paper towel. Okay, see, beautiful paper towel, right? So now imagine I'm trying to go from, oh wait, from this point of the paper towel to this point of the paper towel. Okay, but now when I want to cross in the normal universe, I have to like walk all the way across. I have to walk the whole distance. But if a wormhole exists, we can cross through time and just get to the point. Quick thing, if you watch Stranger Things, they kind of use the same explanation in the show.
so, wormholes. So people like in the movies they cast them as water slides, but they are not water slides. Like in the movies you see them going through all these like fun colors. That's not it. Basically it would just look like you're just traveling through space. But another factor is you're also traveling through time. So yeah, as like Sujin said, I'm just going to rip up my homework here. As Sujin said, we are moving from point A to B, and when space time folds and we like poke a point through it, then it's like we're there, but it's like that. Yeah, so that's wormholes.
We do have to keep in mind though, if we wanted a wormhole to remain, safe and something we could like actually travel through without dying, I guess, or disintegrating, it would require exotic matter with negative energy density to basically like counteract the gravitational forces that would otherwise cause it to collapse. And since such matter has not been observed, the actual statistic possibility of wormholes existing is very low. So, Sigma, thank you so much for listening to episode 2 of Star Talk Junior, and stay tuned for the next episode. And as always, stay curious.